The Robert H. Smith Faculty of Agriculture, Food and Environment of the Hebrew University of Jerusalem is located in Rehovot at the Central Coastal Plain of Israel. The research conducted in the laboratories of Professor Shachar Abbo, Dr. Tzvi Peleg, and Professor Yoshua Saranga focus on the wild progenitors of the Near Eastern cereal and legume crops, their domestication, ecophysiology, and potential utilization for crop improvement.
A considerable number of today's major croplands, such as wheat, barley, chickpea, and lentil, have originated and were domesticated in an area known as the Near Eastern Fertile Crescent, from wild plants which still thrives in this area. For example, in the north of the Sea of Galilee in Israel, we can still find in the same habitats wide stands of wild wheat, wild barley, wild oats, and occasionally also wild pea and wild lentil, all of which are the direct progenitors of our present grain crops.
Croplands differ from their wild progenitors in a number of morphological and physiological traits. Domesticated croplands are dynamic genetic entities that accumulate both adaptive and neutral genetic variation under domestication, including unique morphological traits that are absent from their wild gene pools. As demonstrated in our recent paper in Trends in Plant Science, we cannot assume that all the morphophysiological parameters distinguishing wild progenitors from their derived cultigens are necessarily associated with the ancient domestication episode. Based on comparative studies of the Near Eastern cereal and legume crops, in this work we propose a conceptual framework to distinguish between genuine domestication traits and variation that have evolved post-domestication. Such a distinction is imperative for the understanding of past domestication episode and has bearing on future crop improvement as well. We suggest that the domestication episode involved mostly crucial traits without which profitable cultivation is impossible. A classical example for such a trait is the hard seed coat typical to the Near Eastern grain legumes that, unless scarified, will remain dormant. Once crucial domestication traits are identified for any crop species, it follows that the other parameters differentiating the respective present-day domesticated germplasm and its wild progenitor are most likely to have evolved under domestication. An important issue concerns the visibility of the domestication traits in the archaeobotanical record. The most diagnostic trait of wild cereals is their brittle rachis as compared with the non-brittle rachis of the domesticated cereals. Unlike the brittle spike trait, growth habit or vernalization requirement usually cannot be deduced based on carbonized archaeobotanical material. Seed size, on the other hand, can be documented quite easily in carbonized material. But due to the phenotypic overlap between the wild and the domesticated gene pools, it is not a diagnostic trait vis-à-vis domestication, but could be a useful descriptor of evolution under domestication.
The classification we propose is useful for reconstructing the evolutionary history of our croplands and for deciding what reliable traits can be employed for delimiting the time frame of the domestication episode.